All right, today we're diving into a concept from the very edge of theoretical physics that honestly sounds like it's pulled straight from a science fiction movie. But it's backed by some seriously heavy mathematics, and it's an idea that could completely flip our understanding of reality on its head.
So let me ask you this. What if our three-dimensional world, everything you can see, everything you can touch, isn't actually the fundamental reality? What if it's all just a projection, a kind of cosmic hologram? Yeah, that is the wild possibility we're going to explore.
To really get our heads around this, we're going to follow the clues, almost like a cosmic detective story. We'll start with the basic idea, then dig into the black hole paradox that kicked this whole thing off. We'll see how information might just live on the edge of space, look at the mind-bending math that supports it, and really understand why this matters. And then, finally, we'll see where the search for actual evidence stands today.
Okay, so let's jump right in with the core idea. And I'm warning you, this challenges our most basic assumptions about the very fabric of reality itself.
You know the best way to picture this? Think about one of those little security holograms on your credit card. It's a totally flat, two-dimensional surface, right? But when you look at it, it projects what looks like a three-dimensional image. The holographic principle basically suggests our entire universe works the same way. All the information that makes you, me, and everything we see could be encoded on some distant two-dimensional boundary, and our 3D world just emerges from it. So where in the world did an idea this bizarre come from? Well, it didn't just appear out of thin air. It was actually born from a really desperate attempt to solve one of the biggest puzzles in modern physics, the black hole information paradox. Okay, so here's the problem, the big clash. You've got two heavyweight champions of physics. In one corner, you have Einstein's theory of gravity. It says that once something falls into a black hole and crosses that point of no return, the event horizon, any information about it is just gone. Poof, lost forever. But in the other corner, you have the fundamental laws of quantum mechanics, which state absolutely that information can never be destroyed. So for decades, these two pillars of physics were in a total standoff.
Now, to solve this paradox, physicists had to get really creative, and their solution ended up being the very first clue that our reality might be something like a hologram.
The big breakthrough came from physicists Gerard Hooft and Leonard Susskind. They proposed something radical. They said, what if the information doesn't disappear inside the black hole at all? What if instead it gets sort of imprinted or encoded on the two-dimensional surface of the event horizon itself? This was revolutionary. The idea that all the info for a 3D object could be stored on a 2D surface, well, that was the first real hint of the holographic principle. And this led to a massive leap in thinking. I mean, if this works for a black hole, could it work for the whole universe? And that's the holographic principle in a nutshell. It's the theory that all the information inside any 3D volume of space can be fully and completely described by what's happening on its 2D boundary.
But look, a cool idea is one thing. You need some kind of proof, right? And while we don't have physical proof yet, a huge breakthrough in string theory showed that this wasn't just some philosophical idea, it was actually mathematically possible.
So you can see how this all unfolded. The paradox pops up in the 70s. The potential solution starts taking shape in the 80s and 90s. But the real game changer, that came in 1997, when a physicist named Juan Maldacena made this incredible discovery that just connected all the dots. What Maldacena found, at its core, was a mathematical proof of concept. He described a specific theoretical universe with gravity, and then he proved, mathematically, that it was perfectly identical to a simpler, lower-dimensional universe without gravity that lived on its boundary. It was like he'd found a perfect dictionary to translate between two completely different physical languages. Now, it wasn't a model of our universe, but it was the first solid evidence that a holographic reality could exist.
Okay, so, wild idea. The math seems to work in some kind of universe, but so what? Why should you and I care? Well, because if this is true, it doesn't just tweak our understanding of physics. It completely rewrites the rules of reality.
For one, this could be the key to the holy grail of physics, a theory of everything that finally unites gravity and quantum mechanics. It also suggests that space and time, well, they might not be fundamental things. They could be emergent properties, kind of like how wetness emerges from water molecules. And in this picture, our reality could be emerging from a much deeper layer of entangled quantum information living on the boundary of the universe.
And that brings us right back to today. Where do we actually stand on this? It is so important to remember that while the math is beautiful and the idea is compelling, this is still a speculative theory. The case is definitely not closed.
So let's be super clear here. The bottom line is, as cool as this idea is,
There's zero direct experimental proof that our universe is a holographic projection. But that final word on the screen is pretty important. Yet. Because the search is very, very active.
This isn't just sitting in a textbook. Scientists are out there actively hunting for clues. Some are poring over data from the cosmic microwave background, the afterglow of the Big Bang, looking for tiny patterns that might hint at a holographic structure. Others are doing these incredibly complex experiments with quantum entanglement, trying to see if that's the thread that weaves space-time together. They're all looking for that one little crack in our 3D reality that reveals the 2D code underneath.
And that just leaves us with this one kind of mind-bending thought to chew on. I mean, what does it even mean if our world, our bodies, our thoughts are all just complex projections from some distant surface? It suggests that, at its most fundamental level, reality isn't about space or matter, it's about information. Whether it turns out to be true or not, the holographic principle forces us to ask one of the deepest questions there is: what is reality, really?